Okay, this question was an absolute car crash in the exam. Don't know why. So, they're describing an investigation that I know we haven't done. You're going to get descriptions of investigations that you haven't done in the exams. That's how they're going to hit those sort of AO2, AO3 stuffs. So, mesh bags, each containing 50 leaves. So starting with 50 leaves, buried in the litter layer in June. And there's June there. There they are. That represents 50 leaves. Remaining biomass. So that's the biomass that is left. So here we're losing mass. Those 50 leaves are weighing less and less. Every month when we take them out, there's less and less leaf left. So over time, as we go along there, there's going to be less leaf in the bag. Now, you know, it's not rocket science. That is not disappearing. This is not, you know, somebody coming and stealing a leaf every so often. We're looking at dead leaves. So we're looking at decomposition. So what does that? We're looking at saprophytes. We're looking at fungi. We're looking at bacteria. So you bury your bag in the leaf layer and they're invaded by fungi and bacteria, and the fungi and bacteria population is then going to be quite slow at the start, increase, and then level off as it starts to run out of food. That is kind of it. So, suggest why there was so little change in the biomass during the first month. First month, lag phase. The population of decomposers was low. Suggest explanations. Give a reason why it then sort of plummets between August and October's there. Why does it go down so quickly? August to October. The decomposer population increases rapidly. So hey, they've got 50 leaves to go at. Yum yum, loads of food. They're going to go into exponential growth phase, and they're going to therefore consume more of the leaves. And then October to March, we're slowing down. Why are we slowing down? We've still got quite a lot of leaf left. We've got 30% of the leaf left there. Why is it slowing down then? What happens in October? This is winter. So the cooler temperatures reduce decomposition. And of course here, March, April, May, it's starting to warm up again. It's not going down very far, and that's possibly because you've got now less than 10% of your leaf left. So, at the start of the experiment, so it's up here, the mean nitrogen content, so we're not talking biomass here, the nitrogen content was 0.6 grams for each leaf. So we're starting off with 50 times 0.6. Calculate how many grams of nitrogen were lost from a bag from August to October. So, two things going on here. I need to draw a line up to August. And draw a line up to October. and August line is at 90%, and October is at 30. So in between those two, so August to October, lost 90 minus 30%, which is 60%. And at the start, nitrogen content is 50 times 0.6, which is 30 grams. Now, do I need to work out what 90% of that is? Let me just have a think. I don't think I do really. We've lost 60% of it. 60%. Doesn't matter because it's per leaf. So 60% of 30 grams equals, 60% means 60 over 100 times, that's the maths word for of, equals 18, and it's in grams. Oh, that's quite a lot of calculating, isn't it, for 2 marks? But it's quite a simple calculation. Okay, what name is given to fungi that are involved in the breakdown of leaf litter? So we know that fungi and bacteria, they're 2 different things. They're both saprophytes. So saprophytes. Name. A chemical in the soil is the end product of bacterial breakdown. This is saprophytes of nitrogenous compounds. So this is the bit of the nitrogen cycle that goes amino acids, decomposition to ammonium, and name it. Ammonium, and I'm going to call those ammonium compounds. Explain how the nitrogen in this chemical, this one here, becomes available for plant growth. So plant growth we're using nitrates, so I need to say nitrifying bacteria, like Nitrosomonas, convert, and it is a convert, they're converting one form to another, ammonium to nitrite, and nitrobacter convert nitrite to nitrate, and of course you can write those words out. So some of the available nitrogenous compounds are lost instead of being taken up by plants. So 2 things that can happen if it doesn't go into a plant. So on my nitrogen cycle, I just kind of sketch it out. I've got absorption, plants, feeding, animals, death, ammonium, nitrate. So that's how the nitrogen cycle goes, isn't it? And then I've got nitrogen gas in the air being fixed into nitrogen compounds, that's bringing it in. And then we've got losses, haven't we? We've got nitrate going up to nitrogen gas, so I'm going to talk about denitrification. And then of course the nitrates, we've got that idea of leaching and eutrophication. So they can leach out of soil into rivers, or be denitrified. I'll just say what that means. Conversion of nitrate to nitrogen gas. I'm going to put the bacteria down as well. This is Pseudomonas. Okay. Phew. F. The experiment was repeated in marshy soil beside a lake. What do we know about marshy soil? It'll be waterlogged and it won't have any oxygen. Explain how the results might differ. So I'm thinking it's anaerobic, this won't happen as much, that won't happen as much. We're going to get less decomposition, so the curve will be much shallower, so a much slower rate of decomposition. The rate of decomposition will be slower. And here's my explain word: because. Waterlogged soils lack oxygen and decomposes are aerobic. And I can refer you can go on the Vindelander website, look at the wooden tablets that have remained since 300 AD, unrotted, leather shoes unrotted, bog bodies, absolutely fascinating. Go for it.